Good afternoon, everyone. Our project name is Imagine, which means that's a better way to find your images. This project is based on web applications. Users can find their own pictures from each event by uploading at least one image. Next, please. So let's just start with project extensions will include problems, solutions, and technologies. Next. For the first problem, it has to find your image in each event such as marathon, concert, graduations. And the second problem is harder when there are many photographers and many of them post images in different places. And the last one is, in order to sell images, photographers have to prove images of each user. By doing this, it will increase many workloads of them. For solutions, the first one, user can find their own pictures easily. Photographers also don't have to group images by themselves because each user can find their own pictures by uploading their image. Thus, the sale can be made easier as well. No, back please. For additional problems and solutions, photographers have to design images and put their watermark on their image to prevent stealing. So we would have the feature that allows photographer to choose a sample of watermark, and our system will put that watermarks on every picture. However, this feature haven't implemented yet, but we would like to do this if we have more time. Next, please. For our project, we use four technologies. The first one, SQL database. We use this to store all information for queuing, such as title, image, description, date, time. And the second one is cloud storage to store all images of an event and get the link to access. And the third one is Flash. It's very suited for web applications using Python. And it also gets started easily because there is a little prepared code. And the last one, fastness. It is an image preprocessing for extracting the feature of image and compare with other. And the next, my friend will talk about. Yeah.
Can you hear me? Hello, can you hear me?
Yes, I can hear you.
Okay, so after my friend talk about what is our project, what is made, why this project is made, the problem, the solution, and the technology that we are using. Next, I'm going to talk about the technique that we are using in order to create this application. This application contains with the three main parts. Is a face, and the first one is a face detection. So start, let's go to the flow where the organizer have to create an event and add a pictures into the event. Over here, you can see that in this case, organizer has shows 10 images. And when each images has been uploaded to our system, each of them will be using the face detection technique to detect the face in each images. However, there are plenty of face detection algorithms and techniques out there. We chose to do an experiment with three of them. First one is histogram of oriented gradient. Second one is convolutional neural network, and the last one is hard cascade classifier. However, in the end, we chose to use just the HOG, or the histogram of oriented gradient. The main reason is because the HOG has a combination of the points from both convolutional neural network and from the hard cascade. In the convolutional neural network, it is the deep learning technique where implementing this one, it could improve the accuracy of face detection. However, because it is a deep learning technique, it could consume a lot of, it could be like computationally demanding, which means it could slow down the system, which is not the thing that we want. So we jump to the third one where it is hard cascade. However, hard cascade, it is faster for sure, but it has a problem about the scaling factor, where the hard cascade has been trained in a specific size of images, which means if the images that has been put to the model is too big or too small, the accuracy rate would be decreased as well. That's why we chose to use the histogram of oriented gradient where it could contain the pros and cons from the both sides. Now, after we do the phase detection, this is the next flow. The next flow of the process is to do the phase embedding. As my friend said that we use one of the feature is FaceNet as well. FaceNet is a pre-processing technique where you have the pictures, which is the vector of RGB scalar, and it will take this deep learning model will take those information and trying to change them into get the features, trying to extract the features and put them into the 128 dimension platform. As you can see here, after the images has been put to the embedding model, it will, the model is now for the model itself part, we have tried with the FaceNet, but here's come the problem. FaceNet could come with a it has a very good accuracy, but it could come with a very time-consuming process as well. So we tried to figure out some the other technique to deal with these problems, and we found ResNet. ResNet has been shortened from the residual net. What it does is that it's trying to solve the problems of vanishing gradient. Or if you might not know, in deep learning we have the terms called layers or hidden layers, where more layer we have, it could result in the better accuracy of the model because model have more time and have more space to learn some things. But problem is when the model is too deep, it could create vanishing gradient descent problems, which is model stop to learn suddenly. So ResNet, they implemented the function called skip connection, where it checks whether the input from the previous layer is the identity function as output layer or not. Sorry, my bad. The output function from the previous layer is the same as the input from the next layer or not. If it is, it will change. It will skip the layer and then go to the next one. In this case, it will reduce the data or the features to be overtrained. As you can see on the right images there, this image came from the ResNet report themselves. They claimed that, as you can see, when they trained on the Shifa 10 and used the ResNet and use the normal neural network here. Sorry. Okay. So as you can see, had when the layers number of layer is increasing, it took it has a training the training error has been started to grow since its iteration. So this can confirm the problem of the gradient descending. Now there's also the algorithm of the model that trying to fix this problem before, such as VGG19. This one, as you can see here, he trying to doing they're trying to solve this one by using some technique called pool layout. But then I will not go deep into this one since it's not related to our topic, but we will go to this one instead. In the residual network, you can see that we can have the higher number of layers while reduce the problems of vanishing gradient and have a deeper connection. Sorry, have a deeper layer for the accuracy as well. And this is the test in the paper, comparing between the plain or the vanilla neural network and the ResNet, where as you can see here that with the 18 layers, plain and ResNet, they have the rate of error is about the same. While when the layer is increased, as you can see here that plain has significantly increased, while ResNet is actually the same or even less. And that's for the phase embedding, and the reason why we use ResNet as that phase feature extraction model. Now go to the next step is a face comparing. After the organizer has uploaded all the images and all the images has been do the pre-processing and capture the face of each, cap the features of each faces in each images. When the user comes, they want to find their own images. What they can do is that they could take the photo or they can choose the file from the system. And the system will took that image, those images, and do the similar thing, face detection and face embedding. After that, they're going to use those features to compare with the with the unknown faces in the event to find the image that has the similar face in that. So the function that we use for comparing is the Euclidean norm. So the norm is the function that accept the vector value and then return a scalar value to interpret the length, the size, or the magnitudes of those vectors. So let's make it simple here. It's very similar to the Euclidean distance, but the one vector of Euclidean norm is one Euclidean distance. So it means that Euclidean norm will compare all of the vectors instead of one by one and return the result of similarity. And next, it's going to be the demonstration part of our program. Let me stop sharing screen for a second. Okay, can you see the screen now?
Yes.
Okay, so because this is our term project, and which means that we have to do we couldn't spend our like 100% to this project since we have to spend other part to do other term project as well. So we trying to finish the main features here. So over here, when you come to this app, to this website, first thing you can see is that you will have the username and password there. There will be two roles in the system. The first one is the admin or organizer, and the second one is the user. So let me put it here. I log in as admin, and when I go to the event pages, event page, as you can see here that I have put some event already. So what the organizer can do is that they will have features to edit the event itself, delete the event, and also add a new event. Let me show you the step of add the event first. When I click here, it will add to this page where I will do this. I will like make some simple quick event since to save some time for us. I will put just one image over here. Let's put this one. Okay, I will put just one image for the sake of speed, because I didn't. Okay, I click download it. I click save it here, and on the back, if you do two processes, where the first one is face detection, it detects its face in the images, and then do the face embedding. After that, they could upload all the information to the database. Now you can see here that the images have been added to the event. So if you click to the view part here, it will load all the images of the particular event. You can see it here. And you can edit it here as well. But before we go into the part where we do the face finding or filtering, I would like to log out first and assign and log in again with the user password with username. Sorry. Yeah, you do remember the password?
You can use Tiew.
Okay.
And Tiew.
Okay.
Oh, I think we can sign in.
Okay. No, okay. So we forgot the password. We already do that because we tested a lot and we have a lot of account tests. But if we log out in the user password, something that you could see is that the delete and edit and add bottom will be gone because those things will be only allowed for the organizer. Okay, so go to the face comparing part. Over here, you can see the button where it says that find yourself. So I will go over here. Oh, I cannot open the camera because right now my camera is set to the zoom. So let me stop sharing the video for a second and refresh the page. Okay, as you can see here that I have the camera opened and I can take the photo. So in this case, in this event, there's no they are not my face in that event. So instead of using the photo, I'm going to choose the file instead. And here I will choose a file for like people who existed in that event, such as my friend here, Theo. I can choose multiple images as well for the sake of accuracy. And then over here, I can choose the similarity value, but the optimal similarity value would be 50%. But if the images that it returned is like has a lot of error, you can change this value as well. So when I click done, it will load and find all the images in the system. It could take a second since you first it has to do the face detection and face embedding in the images that I have put first, and after that it's going to compare to every images. Now, as you see here, here's still, and it seems like all the images of Theo is over here. But of course, I can. What if I like trying to find other people? So JD, can I use your images? I will say okay. So I'm going to use JD image as well. Okay, to find the image of JD in this event. I click done. It will do the similar process. Oh, it turns out that the image, it cannot find image of JD in this event. But something that we can do is that we can choose to decrease the similarity value over here. So I will go around 43 and click go again. And here we go. We can have the image of JD. However, you might notice that there's other images as well that haven't been shown, such as this one. Since the face of JD is like looking at not looking front to the camera, so it's very difficult to detect the face. And even it can detect the face, it's also very hard to compare between the face that we just gave, since the picture that I gave to it is the frontal face, while this one is the side face. So you can see that this one is the drawback of. You can see that it requires some good images as well. But this part about the performance or about the optimization, my friend Tiao, we're going to talk about this in the next section. So let me stop sharing the screen now and go to Tiao.
Okay, let me share a slide.
Oh, sorry, I will share it. Sorry.
Okay.
Okay, so can you see the screen now?
Yes. Hello, I am Theo. And in this section, first I will talk about the expected goal that we plan before we start the implementation. And then I will talk about the goal that we can satisfy after we finish the implementation. Okay, and first goal is admins or event organizers can upload events images. And this goal we can accomplish by we allow the event organizer to create the event on a website. And on that particular creating event, they can upload all of the event images. And once they finish creating the event, then this particular event will be shown as a user page. Next, please. And the second goal is users or the attendees can search for their images in the events. In this goal, we can accomplish after the user click view at the event, then it will have Find Yourself button, and once they click the button, it will navigate to this page. And in this page, they can upload their images of their face from the local files, or they can take a selfie, or they can even do both. And once they finish upload their images, then the system will return the images of the events that has their face on it. Next, please. And the third goal is the accuracy should be reasonable. This goal we can accomplish, but with a certain conditions. The first condition is the images, the uploaded images must be well lit with a frontal face. And the second goal is the similarity value between the uploaded images and the event images must more than the value that we set. And by default, the appropriate value is 50 each, which we take from the experiment, and we found out that most of the case, most of the images from the events will be that has the user face will be returned, and the accuracy of this group of images is quite high. However, if the user did not satisfy with the result, they can adjust the similarity value. If the similarity value is increased, then the accuracy of course must be higher, but the amount of the images will be lower. And on the other hand, if they decrease the similarity value, the accuracy will be worse, but the amount of the images will be more. Next, please. And the last goal is the program should load fast for attendee site. In this goal, once the event organizer finish creating the event, then all of the images will be uploaded to the Firebase storage. And after the uploading done, then all of the images will be pre-processed as my senior said. It will be face embedded and something like that. And once the pre-processed done, then it will store in the database. By doing this, not only it will decrease the time, the user have to wait, but it had a trade-off, which is the event organizer have to wait for a longer time. This is because the two major reasons. The first reason is the Firebase storage that we use. It is free tier, which will take about 1 second per 3 megabyte each images. And the second reason is the pre-processing step that we do. It will take about 10 seconds per one image. By combining to process, it will take about 11 seconds per one image. However, by doing this, it will also reduce the repetitive jobs for a server. That's all for the goal of my project. And my PO will talk about it later.
So I just noticed that we just took our time, but I will go this one very quickly. This one is just the system diagram that we have created for the project. And there are some problems that we could improve in the future as well. As you can see here that the problem in this one contained in two steps. First thing is the real-time database. We kept the full resolution images. With this one, it could reduce the performance of our project, of the application as well, since it has to download full resolution images all the time. But actually, user will not tend to see the full resolution until they click on the images. So instead of that, we could improve the performance by doing that. And the last one is the computation service. This one, because we do everything with the endpoint, image embedded and image comparing at the same machine, we could improve it better by separating this process into the other instance, where the first one doing normal website and the second one do the computation processes. So this is the last thing. This one I already talked about when we should doing those face detection, face embedding, and face comparing in the background engine. So it's something like when the organizer trying to upload the images, when the images has been uploaded, it will be done. But in the background, the other engine will do the fast processing on those images. So it could improve the performance and UX for the user. This one, my friend already talked that we could implement the watermark and using the different and create a different resolution for each images as well. And as you can see that there are also some performance issue when we do the phase comparing. It could take like a few seconds. We could do it better with the other algorithms such as approximate nearest neighbor, but we haven't implemented yet because it has to like we have to submit our project within the period of time of the term project. And that would be all for today. Thank you for your attention.